I have always wondered how, when you download something, for example, let me just grab any file here online. This is just the OpenJava JDK, whatever. I'm downloading this, and then I get a downloading progress bar right here. Do you see that? And depending on the progress of the download, I get a status output. And the update is made in place. But when I print anything using my C code, for example, in using printf, well, I only append to the console. So how does it work to print to the console and replace lines in place and have this kind of output? This is completely, I really find this fascinating. This is really cool. And I would like to inspect today how to do something like that. And it should be very simple. I already found out some basics. And to do that, let's just create a clear directory. It's called character animation, and let me open Vim and include standard.io.h. We're always going to need that one. And then we're also going to include uni standard.h. That is a standard library. And then let's create a main method and print something to the console. So let's do printf hello world. So there's our hello world. I'm missing a new line and I'm saving it to character animation.c. So that is our new file. And over here in this window, we have this new file created, and let's compile it. And now we have an output binary. Let's execute that, and we get the hello world. So that's basically it. And if we print more than a single line of code, then we get a multi-line output. So by calling printf, we always print below the last line. So how does it work to animate something in line? And that is quite interesting. I found out that there are characters that you can pass to printf, and they will move your cursor to the beginning of the line. So let me just pull some documentation up. Printf, what do I Google for? Cursor position. That's quite interesting. So there is here's some guy just describing that you can define these functions here, or these, well, yeah, let's call them functions, or what are they called? Macros. These macros to position the cursor at any point or any position in the console. This is quite cool, and you can basically draw characters at any position in the console. Then that's good. But even simpler, I think there was the so-called \r operator, just like that, and that is a carriage return or so whatever. I don't know what it is, but this replaces the cursor to the beginning of the line. So let's see if we can use it. For example, let's keep the hello world, and let's replace the new line with this \r, and let's write hello Daniel. I have never tested this, okay? So let's see what happens. Let's compile this and execute it. And as you can see, the output here is hello Daniel. Maybe I should add a new line. So that means the hello world was written, then the cursor was placed back at the beginning of the line. So cool. And then hello Daniel was printed over that hello world. I find this so fascinating. Probably you're going to think, Oh, this beginner guy, this noob, this noob doesn't know anything, but I find this just so cool. So let's try to print hello world and then override this with just, for example, by. Let's see what happens then. Oops, like that. And here's the output of that. And as you can see, the first 3 characters were overwritten by the by, and then the rest of the hello world remains. That means we're not deleting the entire line, but we're actually we're really just placing the cursor at the beginning of the line, and then we are printing stuff over the existing characters. So let's just try to play it with this a bit. Maybe we can get, maybe we can create an animation. And I was thinking to do some kind of loading animation, and that is going to be a rotating cursor. For example, let's do a loading output right here. That is loading. And then while true, or let's create an integer, loading is true. Or no, I don't think we need an integer. Let's just do while true. And there is no true in C. Yeah, great. So while 1, we're going to print something. And how do we do it? We're going to print a \\. That is just going to print as a \. Wait, let me just show you in Paint what I want to do. This is so simple probably that it's stupid to explain, but I really like to keep things very simple also, because otherwise I don't get done anything. So I would like to print a slash sign that turns into a dash, that turns into a /, that turns into a, what's that called? Pipe operator, that turns into a / again, and then a dash, just like that. And this will appear to be a rotating line, just like that. And that is the goal of this animation. Because I have seen something in some software in the past. Yeah, so let's just see what happens. Of course, it doesn't compile. Why doesn't it compile? Printf. Yeah, of course, this is probably the issue. So, yeah, now it's printing a lot of backslashes right there. But we don't want that. We want to print a \. Then we want to return, and then in its place I would like to print something different. But I would like to introduce a delay, and for that we imported the other library, the uni standard. I think that is Unix standard or something. Let's have a look. Uni standard, and there was something like sleep, I think. Yeah, there is a sleep function that we can use, unsigned in seconds. Why not milliseconds? I don't want to use seconds. Can I pass something smaller than seconds? No idea. Then let's just sleep for 1 second. And then we're going to print a dash. And we're going to sleep for 1 second again. So let's see how that looks like. Probably I messed up somewhere. Of course I did. We don't need a \, to print a dash. Okay, we're loading, but nothing is being printed. Why is nothing being printed? We have to make sure that the output is flushed to the console. To do that, we can use flush, I think. And we have to specify an argument. Usually terminals are flushed, the buffers of a terminal are flushed when you use the new line character. So a line is printed as a unit, but right here we want to print and generate individual characters, so we have to flush to the console between the calls. Otherwise, we are just writing stuff into the buffer, but the console never really prints it because it's waiting for a flushing character. So let's check out the documentation for flush. That is flushing a file stream, and I think the standard IO is 0 or 1. flush standard out. I mean, not standard IO. Flush standard out. I don't want to go to Amazon. Probably I can just flush 0. Flush in C. This is Windows documentation, but it should be similar. Oh, whatever, come on. I'll just flush 0. Let's see what happens. Oh, okay, the character is being printed, and as you can see, the cursor is being moved to the beginning of the line, which is good, but then nothing else is happening. I'm not sure why. Oh. As you can see, we already have an animation right here. I would like to make this a bit better by also printing other characters. So let's introduce a new method that's going to be called void print character. We're going to receive as input a character C, and then we're going to call all of this stuff right here. And let's replace this with the character that we're passing as input. So we have a dummy method that just accepts the character and then does the flushing and the sleeping. So let's just call in the while loop print character. And in here we can do I think we can pass the backward slash like this. Then we're going to print the dash, and this should have the same output as the previous animation. No, it doesn't. There's an issue somewhere. Expected character, but argument is of type character pointer. Oh, damn it. So I'm passing a string in here. A character is probably with single ticks. Yeah. This is going to be the issue. Or this is going to be the solution rather. Yeah, okay, it's working. So after that, I would like to print a forward slash. Then I would like to print a whatever straight line that is. And then, oh, that is already it. Then we follow up with a backward slash. Now I don't like that we sleep for an entire second. Why? Wait, C sleep milliseconds. Use sleep, there's a use sleep. Older POSIX standards. But why is it only... Why is the sleep method only accepting seconds? What's the point behind that? Yeah, but okay, let's use sleep. Use sleep, and then let's do 200 milliseconds. There's a warning. But let's see if it still compiles. Oh, it seems to work despite the warning. But it doesn't really... No, I think there's an issue that uSleep is not working. I think the method is not defined anywhere. uSleep. Oh, it's using microseconds. Oh, okay. So 1 microsecond is 1,000 milliseconds. So that would be 1 millisecond. And that would be 10 milliseconds. That would be 100 milliseconds. Let's do... I can't use underscores here probably. Okay, this should be half a second. 500,000 milliseconds. Yes, that looks good. And let's make this faster. And let's have a look at the terminal output here. This is the big moment. As you can see, we have a loading animation. Whew. That's really cool. I would like to make this a bit better looking. Oh, it's still going on here. It's still loading here. What else can we do? We have a rotating slash sign. That is already very cool. Can we print? How about we print the loading at the beginning of the line? How would that work? So we have loading, and then after loading, we have this loading animation. So that would be loading. And then here we print the character, however we carriage return to the very beginning, which is not what we want. Nah, this is probably too much overhead. I'm just thinking of, we now know how to animate something at the beginning of the line, but we don't really consider that there can be other text in that same line. And I would like to figure that one out as well. So maybe it would make sense to find out how to move the cursor back by one position. So C move cursor position. Let's have a look. The issue is here, somewhere someone mentioned that these cursor commands are not standardized, so they might vary by the terminal you're using, but most terminals will probably be fine. So here we move to the left, X columns. Yeah, that's what we need. let's just, okay, move to the left by X columns. And I would like, actually, if you're interested in that, we could take this to a whole different level by creating an animation purely in the console. That would be really cool. For example, a jumping ball or whatever. So far, most of the graphics videos we have done with STL, the graphics library, but we could do all the graphics in the console using characters. I'm serious about that. Okay, so this is moving to the left X columns. So we can move to the left, for example, one column. Then instead of the formatting is a bit off here. So instead of doing a carriage return here, or just a return, whatever that is called, we can print the character, and then move back one character. Maybe like that. Let's see how that turns out. Then we can print something. We can print something, for example, like that. Then we can print the character. After the character is printed, the cursor is moved back by one column. Then something else is being printed, something else, something else. Yeah, let's just see how that looks like. I'm just wondering about the new line at the end of that. I would like to have a new line at the end of all of that. Printf, new line. This should be a new line here. But then also we should add at the end of this new line, we should probably also move back once. So we can probably do the following. We print an individual new line like this. Okay, let's see. I think no, this is not going to work. Let me just show you. This is not going to work. Yeah. As you can see, it's performing the animation once. It looks cool, and then it's progressing down. So not really what I intended to do. I actually want the new line after this part of the output here. Because right now, let me show you what it's looking like right now. No. Wait. Let's clear that and compile. Oh, no, it's working well. As you can see, the cursor is constantly positioned before that animation part right there. But that's fine. Actually, that's what I wanted to achieve in this episode. So if you enjoyed this was a really simple episode, and I found it very cool to play around with the cursor positioning in the console in order to generate animations in the character-wise output of the terminal. So that is something that's very cool and maybe even a bit more interesting than classical graphics. Or no, before I quit this, I don't want to stop here, because this is so interesting. Actually, I would like to really take this to a level where we have an animation in the console. So let me just do the following. How about we look up clear screen not bash, C printf. Because if we can clear the screen and we can then print to this console, we can basically print an entire frame of data or an image, ASCII image or whatever. And then we can clear the screen again and draw the next frame. So we don't just redraw the animation on an individual line level as here, or on an individual character level by moving the cursor back one column. But how about we just delete the entire screen and then generate an animation based off that? So there's a clear screen function here. But let me just have another look at some other sources. Basically, I would like to move the cursor back to the beginning of the terminal. Let's have a look at Reddit. Move the cursor to the home position. That is it. Erase from cursor to the beginning of the screen. Or that might be it as well. Erase from cursor to the beginning of the screen. It doesn't really matter. Let's try this one. Erase from cursor to the beginning of the screen. Oh no. Okay, let's try this one. So we are going to, I would say, let's throw out all of this. Let's keep the while loop. Let's throw out all of this as well. We need the useSleep method, and we're going to wait 500,000 microseconds to do whatever printing. Let's just printf hello, and we're going to printf hello at a rate of 0.5 seconds. Let me just compile that. Okay, so it's printing hello world at hello at a fixed rate. Then I would like to clear the screen. Let's just try this. Void clear screen. And we're going to printf, and we're going to pass as input this string right here, this code. Let's see what happens. Okay, it still looks the same. Oh, of course, because we haven't called clear the screen. So let's do clear screen here. And now I would expect only one hello to be printed. And that is the case, yes. No. Wait. Oh, it's printed up here because no, we didn't clear the screen. We moved to the beginning of the screen, so we executed the first loading printout, then we printed hello, and then we moved back to the beginning of the terminal and printed hello. Oh, this is so cool. This is interesting. I love tinkering with this kind of stuff. Then, so here we're printing hello. Clear screen. Let's forget about this loading right here. And so this is moving the cursor to the beginning of the screen, but actually I would like to really clear the screen. Erase the entire screen. Oh, this one looks good. Let's see how that looks like. Okay, let me clear it manually, and let's call the... Oh, okay, that looks interesting. Why is the hello moving down? Why is it moving down? We are printing hello. Then, new line, we are clearing the screen. But we don't move the cursor back to the beginning of the screen. To do that, we can move the cursor back to position using this right here. Okay, and this is printing hello in a new screen. Okay, that's good. That's awesome. I can just leave that running, doesn't matter. So we are printing hello, we are clearing the screen. Then we are calling useSleep. And what do we do next? Now we can print something. We can draw an animation. So let's do a, well, I actually already did a bouncy ball in another episode. I'm just thinking, is there anything else we can do? Maybe something like a screensaver. Print screensaver. And we loop over all the x coordinates and then also over the y coordinates. And here we have to first define how many pixels there are. So we have a width in pixels of, I don't know how, or not pixels, characters, but how many characters do fit on one line? Let's just do 100, and a height of 200. And we are going to print. We're first going to loop over, no, wait, the height is way too high. So we are going to loop over int x starts from 0. X starts from 0. Then x is going to move up to width and is being incremented. And then in a nested loop, we loop over all the y values. Y is smaller than height. Y plus plus. Oop. So, and here we can printf, and let's just print a dot character, and at the end of printing all the x's we can print a new line, and this should print characters. It doesn't because we haven't called the print screensaver method. Let's just, I'm not really happy about print screensaver. Let's just call it ASCII animation or console or whatever. No, animation. Let's just call it animation. And then we clear the screen. We call animation. And this right here is our animation. As you can see, it can be a bit wider, but less high. So let's go back up here. Let's do a width of 150, for example. And how many lines are there even in my terminal? Maybe, what is that, 30? Let's try 25 and see if that fits the screen. Oh, I think I'm mixing up the width and height. But X is, yeah? Why is it not working? I'm calling printf for all the Y characters here. Yeah, that's obviously wrong. So let me just do a string replace X with Y on this line. And let's do a string replace Y with X on this line. And I think this will work now. No? Why is this not working? X is 0. Of course, now we have to also swap the height and the width like that. And let's check out the animation. And it's way too wide. Way too wide. Let's try a width of 1 or maybe even smaller. Let's do 80 and see how that looks like. This actually fits my screen. Let's make it a tiny bit narrower. And this fits my screen perfectly. Okay, so this is now the printout of the, this is now the animation pane. And now we can actually also animate something. And we are going to, how do we do it? Animation. Let's call this visualize. And we are going to visualize a, are we going to, what are we going to visualize? We're going to visualize a, yeah, let's just do, no. Okay, we're going to do it again. We're going to visualize a circle. Let's see how that looks like. We're going to visualize a struct circle. Circle. That circle has or consists of a structure here. It is defined as a structure and consists of double X, Y, and radius, like that. And then we're going to draw the circle. And maybe we should draw an array of circles. Maybe that would be more interesting. But let's keep it simple. Let's keep it simple for now. And here inside that nested loop, we can check if the current X coordinate and the Y coordinates are within the circle, then we print a different character. So if, how do we check whether X and Y are within the circle? It's quite simple. If the circle okay, we need a new variable, double distance. That is going to be, we need a bit of math right here. Math, like that. We're going to calculate the square root of x minus circle.x squared plus y minus circle.y squared. That's the distance. Did I mess up anywhere? Yeah, no, yeah, okay. This is the distance, and now we can check if the distance is smaller than the circle's radius. That means that the x and y coordinates, that the point we're checking right now is within these coordinates. Then, so if that is the case, then we printf, then we print, come on, printf, what do we print? Let's print this hashtag character, because it is using quite a lot of, it's consisting of quite a lot of pixels compared to the other characters. So yeah, that's going to be our fill pixel, or fill value. Oh my god. So here, let's do printf point. Okay, let's have a look. Of course it doesn't compile because we haven't even called the visualize method anywhere. Or rather, we have still called the animation method, which doesn't exist anymore. And we need to pass a circle into this method. Now, to do that, we have to also define a circle right here. So let's define a circle, struct circle, that is equal to x and y are going to be, for example, 10, 10, and the radius is going to be 5. And that's our circle. And I think we can use it now. Let's see. Okay. Now the code doesn't compile because we have to link the math library. And we can do that using -lm. I just have to append it to the compilation command, not to the final execution command of the binary. And now it should be working. And that's our circle. It's not very circular, but that has more to do with the characters and the character spacing. But maybe we can balance that out somehow. Can we balance that out? Can we introduce a factor that somehow squashes the circle? What happens if I just do this right here? This is going to be a stupid test probably, and it's going to look ugly now. Yeah. Okay, but this can be used for squashing. Let's call this x squash and define a constant here. This is probably quite hacky, but I just want to have a good circle. Let's make this 0.5. Have a look. This is the worst circle ever, but it's much more circular than before. I'm not really happy with that X squash thing. Yeah, probably the right solution would be just to use a character set that has equal spacing. Well, it has equal spacing, but not in X and Y direction. I'm thinking, is there a good solution for this? Can we properly squash this somehow? This looks really ugly. But I mean, we're dealing with character animations, so what am I expecting? So we have a circle now. What if we print an empty space here? How does it look then? Okay. Let's keep it a dot. And then I would say, just let's keep it like that. That's the default console setting. So yeah, it is how it is. And let's try to animate this. And to do that, we can just, we are clearing the screen. We are visualizing the circle. And maybe before clearing the screen or before visualizing the circle, we have to calculate a step of the circle. And we're passing the address of the circle here. And that is going to be reflecting the movement of the circle. So let's create a new method that is going to be called step. And we're going to pass the circle pointer this time. And here we need to implement a speed variable, Vx and Vy. And also we need to No, let's keep this very simple. Let's not use gravity and all of that stuff. We already did that in another video. Let's just make the ball bounce to and from the corners of the screen. So here we have now a circle. The speed in x is, for example, 1. Speed in y is 1 as well. And we step the circle by updating the coordinates of the circle according to our limits and velocities. So circle x is incremented by circle vx. By the way, again, I'm using the arrow operator here because we are working on a pointer variable. If we didn't use a pointer, we could use the regular the dot operator. So we're incrementing the x coordinate by the speed in x direction. We're incrementing the y coordinate by speed in y direction. And what else is there to be done? Let's just print it out, and then probably we will get some failure. Yeah, the ball is moving, which is already good, but it's moving off the screen. Okay. And I would like it to bounce back from the screen's borders. So if the circle's x coordinate plus this, or no, minus the circle's radius is smaller than 0, then the circle x velocity has to be reversed. It's minus circle vx, like this. Circle radius, of course, we abbreviated that with an r. Then if the circle's x coordinate plus the circle's radius is bigger than the width of the screen, or the width of the printout, the console printout, then we reverse the speed again. And then we can pretty much do the same thing for y. So let's replace all x's in this visual selection using y. And we of course have to check for the height here instead of for the width. So let's check it out. Let's have a look at how our coding turned out to look like. So this is the ball, and it is not really bouncing, well, partially bouncing off the screen. I don't really think it looks good. So if it is bouncing off the screen, then, well, the problem is we're updating the x coordinate and the y coordinate before checking if a border is being hit. So maybe we should do it afterwards. This will probably save us from this animation bug. And I would also say let's reduce the sleep time a bit, for example, to 200 milliseconds. And let's have a look at how that looks like. Why is the screen flickering so much? Does it have to be flickering that much? Or am I doing anything fundamentally wrong? I'm deleting the screen and moving the cursor to the beginning of the screen. Maybe we should clear the screen only once and then move the cursor to the beginning of the screen only using a new method. Maybe this will reduce the flickering a bit. Move cursor beginning of screen, like that. And let's call that method here. Right here. And I would say let's clear the screen only at the beginning of the method once. Yes, this does not flicker at all. Why is there a hello at the bottom of that? Am I oh, I'm printing hello. Why? I completely forgot about that. But let's make use of that. Terminal animation programmed in pure C. \n. Oh, this episode is really fun. I like this one. Why is it not working? Printf. Terminal animation programmed in pure C, and that is our animation right there. And the ball is not really bouncing quickly enough for some reason. So something is a bit off. By the way, I wonder how that animation looks like if we reduce the screen size. Maybe we can make it, we can show the animation up here and code it down here. That would be really cool. So let's get the compilation command from here. I can copy this using tmux and I can paste it up here. Yes, that looks cool. And now I would only like to adapt the width of this. For example, let's make it 60. Ah, no, it was quite well fitting before. Let's make it 70 again. Then the height of that animation is going to be, well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's make it 12 lines. Let's see if that fits. Oh my god, what the hell? What is that? I have no explanation for that. We have a height. I think the circle is initialized at a specific height of the screen. But that is already the bottom border, and because it's beyond the border, the circle speed is being reversed, and that's why it is wiggling up and down. So we can fix that as well by doing the following. If the circle... Okay, so if the circle's x-coordinate minus... Okay, if it's exiting the left-hand border, then we need to do the following. We need to position the circle, so the circle's actual position, not the velocity. We need to position the circle right at circle R, so that it is not going beyond the border. Then we need to do something similar as well here. Let me just put the parentheses here. And here. So circle X is that. Circle X right here is going to be, if the circle is exiting the right-hand border, what is going to be the x-coordinate? I would like to set it at width minus circle R. And if the circle is going, yeah, If the circle is exiting the upper border, then the circle's y coordinate is going to be circle R. That is correct. And if it's leaving the bottom border, then we have to set the coordinate to height minus circle R. Let's see. Okay. Yes, it's working. Although I think that the ball is a bit too big for that screen. So where can we adapt the circle's radius? Right here. It's currently 5. Let's make it 3. It's a rectangle. Oh, great. Why is it a rectangle? Probably that has something to do with the resolution. It's still somehow going beyond the bottom border, if I see it correctly. But you get the point. So let's have a look at the code again. And I would say let's make another circle with, for example, negative speeds. For example, this right here. Circle, that is going to be circle 2. And we can step the... We can either pass an array of circles into those methods, or we can keep them separate. Doesn't matter. Depends on whether you want to extend this in the future. Let's just create another circle. Let's just pass the circle explicitly there and keep things very, very, very simple. Or no, let's create an array. That might be a bit better. So we have a struct circle that is circles array, and that contains, well, has size 2. And it contains, well, it contains a circle and circle 2. I think this is how we initialize an array, right? Why is this not working? C initialize array. Of course. I thought this was only done for structs. Then we can pass in the circles array directly, and we can visualize the circles directly like this. And of course we have to update the method definitions. This is going to be a circles array. I think it should be done like that. And here we have to loop over for int I is equal 0, I smaller than number of circles. That is we're going to set that to 2 in just a second. And let's just go down here and add this thing. And then circle is going to be struct circle is equal to circles at index I. So we're accessing the individual circle. And of course, I would like to dereference or use the address of this in order to make use to modify this circle. Okay, let's introduce a new variable, num circles. That is going to be 2. And in visualize, here we also explicitly define that we only expect num circles, just to be sure. And in visualize, we also do the same thing, visualize. And we receive an array circles with 2 entries. And then we loop over that. So how do we draw the second circle actually? Well, because here we have to check, is that pixel within any of those circles? How do we know whether this pixel is inside any of the circles? We probably have to loop over int I equals 0, I smaller than number of circles. We have to loop over all the circles. And then we have to check the distance to that circle. Circles, yeah, this is inefficient. Probably the circle should be retrieved outside of this double loop, but let's, yeah, never mind. Struct circle is equal to circles I. And the distance is going to be this. If the distance is smaller than r, then printf that. Then we're going to check the other circle, and then we can check if the pixel has been filled. What the hell? No, wait. So we introduce a variable int filled is false, and if it's not filled, then we printf like that. Then we set a point or a dot or a full stop, whatever you want to call it. And if it has been filled, then we set filled to true. So let's have a look at the animation and how it looks like now. Great. Circle. What is the error? Line 77. This line right here. Circle X is incremented by circle VX. Of course, I have to adapt this method to suit the new approach where we use 2 circles. And we can update the speeds inside that loop. Okay, let's see. Yeah, and that's an animation with 2 circles, but they. I want a good animation. That's not a good animation. So let me just refine this. I will go back to this piece of code where we define the circles, and let's define them in a bit differently. One of the circles is moving 0.5 in x direction and a negative x direction, and 0.2 in this, and the other is moving 0.7 in positive x direction and 0.3 here. And aside from that, the radius is going to be bigger now. I'm going to make this one 5, or let's make it even bigger. One is going to be 5, the other is going to be 7. So I want them to look like circles. And then I would also like to adapt the height and make it a bit bigger. And for example, let's make it 15. I hope 15 lines fit into that window. No, they don't. Oh my god. Maybe 13. What's the error here? What's the issue? Ooh. Wait, let me clear the screen and execute this from scratch. Okay, this must be an error in our... somewhere here, I guess. Here we're printing the hashtag, and if it's not filled... Ah, okay. If x and y is within a circle, we are printing it. We are printing a character, but we are still looping over the other circle, so we're printing this potentially twice. So we're doing something wrong. We're doing something very wrong here. So let's make sure that I is smaller than circle and we are not filled. And let's print this. The circles are too close together. We can probably increase the height now to 15. Oh, great. But I think now it's quite good. What does 14 look like? Yeah, this is better. This is now really fitting this terminal window. So we have the printout terminal animation programmed in pure C, and we have the two circles animated in the terminal. Also, what I would like to do is reduce this sleep time a bit. Let's have a look at how this looks like. Oh, that's much better. Much better. Oh, there's a big difference. Okay, so let me reduce that even more. Yeah, that's good. One circle is probably too big. That has a radius of 7. Yeah, radius of 7 is the entire screen in that case. Let's make it radius 3. And the other one, let's keep that other one as it is. Yeah, that looks good. That's a good animation. We could technically also add collision detection here. We could also technically add collision detection here. We could add more circles. Well, let's just add another circle. Why not? I mean, we have prepared all the code, and while we're at it, we can just do it. So let's just create circle 3, and that is yet another circle going. Let's make it ultra slow, and let's make this one size 4, for example. It would be cool if we could color the circles as well. Can we print colored characters? Wait, I have to find that out. So we are passing the third circle also into this array, circle 3, and then we have to also define the number of circles to be 3 so that we are properly handling them. Let's animate them. Yeah, now we have 3 circles, so that's, well, it's awesome. Let's check if we can print colored characters in C. That would be cool, because then we could make one ball blue, one ball red, one ball whatever. Come on, why is my internet always so slow? Please, guys, donate to me. I live in poor Germany, the country that has the slowest speed on the entire, the slowest internet speed on the entire earth. It's horrible here. No, for sure. In any other countries I've been to, there was a much better internet connection than in Germany. It's ridiculous. Okay, so we can set colors and then reset them again. Yeah, let's try that. So let's do one blue. I will just copy that and do it like this. Let me just stop the animation, it's a bit distracting. So we are defining a blue and we are defining a red and we are defining a yellow. This will probably look a lot like, oh, what did I do? Where's my red? This will probably look a lot like a circle, so maybe let's not use yellow but green. Blue, green, and where is my browser? Blue, green, and red. Or how about blue, red, and white? That's probably better. Blue, red, and white. A ridiculous amount of countries have flags that are blue, white, and red. Yeah. USA, France, Russia, all these countries. South Korea, I guess, North Korea, Slovenia, Slovakia. Yeah, you get the point. And then I also need the reset define thing here. So we're doing this, that looks good, and we're going to visualize circles now, and we're going to also loop over, when looping over the circles, we can also loop over the colors. So let's loop over available colors. Where's white? We also need white. And really, at the beginning of this episode, I thought I'd just make a rotating slash animation. What do I end up doing? I end up animating the entire terminal, and animating circles in different colors and all. It's always escalating. Yeah, okay. Let's just make a stupid simple test and see if the colors work at all. So to do that, we can probably just print f. And then let's just pass in ANSI color blue and see what happens. So let's compile. Okay, that is blue. That is good. Good, I'm happy with that. So the colors seem to work. So let's create an... What do we create? Let's create a character array, colors, or a string array, colors, that is going to be equal to ANSI color blue, ANSI color red, and ANSI color white. And what is the issue with this pointer? Yeah, okay, I get it. I have to do this syntax right here. Okay, and we then visualize the circles using the colors. And then when we draw the circles, where do we draw them? Here. We draw them in their respective colors. So let's call printf colors at I. And this only works, of course, if we have as many colors as circles, which is the case in our case, or you could somehow implement that the colors wrap around if you introduce more circles. But we don't need that. I'm happy with 3 circles now. And here let's receive some colors. And the colors are strings, string arrays. Printf colors, and then we printf, after setting this, we printf the ANSI reset. Let's see how that looks like. Yeah, that's it. This is really cool. I really like that. This is so much better than I thought it would turn out. This is... What the hell are we doing even on this channel? I mean, all of this makes no sense at all. What is this even? Nobody's ever going to use this for anything positive. This is doing nothing for humanity. This is just code for code's sake. But actually, somehow this is what I enjoy. Why should I code the 1000th recipe website? Makes no sense for me. Also, it's not interesting, but doing these kinds of hacks, that's really cool, I think. So now we have 3 colored balls. They are all moving inside this terminal window right here, kind of like a screensaver. I find this so cool. This is just awesome. Maybe as a last test, I would like to see how they look like if I replace the space with a simple dot, if I replace the dot with a simple space. And yeah, that might be even better. Depends on taste. Maybe I would say I prefer the dots, the full stop characters a bit more, because that really brings forth the character of the application, that it's a console application. Yeah, it's awesome. That was really fun. So please, in the comments, suggest me some more projects. Don't suggest me anything that makes sense. Suggest me stupid stuff like this, and I will be happy for the rest of my life. I can keep coding these useless things over and over and over. Please don't ask me to do anything that makes sense. Don't ask me to do any business applications. Don't ask me to do any create, read, update, delete the database applications. Don't ask me to try the newest framework, whatever. This is what I love. Okay, maybe one day I will try some frameworks. Maybe. But you have to recommend them in the comments, because I will never find them on my own, because I'm spending my time with that kind of stuff. So, see you next time. Bye.